Last section in chapter 4. Transformation. So a similarity transformation is a dilation or a composition of rigid motions and dilations. Two geometric figures are similar figures if and only if there is a similarity transformation that maps one of the figures onto the other. Similar figures have same shape, but not necessarily the same size. Congruence transformations preserve length and angle measure when the scale factor of the dilation is not equal to 1 or -1. Similarity transformations preserve angle measures only. So if you have not done this already, go ahead and graph ABC.
Do you have a pencil I can draw?
Mm-hmm. You were able.
Yeah.
All right, so we've got triangle ABC. Now we're going to do a translation, and then after the translation, we are going to do a dilation. So just in case you have forgotten or never heard the first time, you have to do these in order. You got to do these in order. So we're going to do the translation first. I'm going to go ahead and find my new ordered pairs by using this translation. So my A prime is going to be -4 plus 5, which is 1. And then 1 plus 1 is 2. B prime, -2 plus 5 is 3. And 2 plus 1 is 3. And then C prime, -2 plus 5 is 3. 1 plus 1 is 2. Yes, Alex. Did I make a mistake?
Yeah,
Oh, no.
aren't going to look the same as your P image because the P image is supposed to be a right triangle, not that.
Huh? Did I graph something wrong?
Yeah, the C is supposed to be -2, 1, not -1.
Oh. Gotcha. Thank you. Of course. I'm using my fancy Flair pens that don't erase. That's the bad thing about Flair pens is they're not erasable. Okay. Thank you. All right, so -1, 2. There's my A prime. 3, B prime. And then 3, 2, my C prime. And then after that, dilation. So we're going to multiply everything by 2. So I have 2, 4. Oops, this is A double prime. 6, 6. And B double prime. And C double prime is 6, 4. Okay. I'm also going to introduce a symbol to you that is not introduced here, but I don't see why you can't start seeing it and understand what it means. If I wanted to compare triangle ABC with triangle A prime, B prime, C prime, triangle ABC with triangle A double prime, sorry, B double prime, C double prime, that one. According to what we just read up here, What can you tell me about these two triangles? Are they congruent? Congruent relations preserve length and angle measure. Are they congruent? What are they? They are similar. See with this word right here, similar? Similar figures? They are similar. So the symbol, we know that this means congruent, right? We know that, right? We know that, right? Do you know what this means? What does this mean? Equal. So similarity is this. Similar. You see how my congruent came from similar and equal? So just that squiggle part is the similar. So I would say that triangle ABC is similar to triangle A prime, B prime, C prime. What? Fancy. It's like a sideways, backwards, reflected S. Okay. Can you guys try? This is going to be really small. For this one, it's going to be really small. Let's just count by twos on the graph. I mean, count by halves. So like this would be 1, this would be 2. Same thing with the x axis. This would be 1, and this would be 2. Can you guys go ahead and try that one on your own? I'm going to pause the video. So you had to do 90 degrees about the origin. What is the formula for 90 degrees? Negative BA. So we go from AB to negative BA. So my C prime is going to be negative 2, negative 2. And my D prime will be negative 2, 2. So negative 2, negative 2. And negative 2, 2. All right, and then after that, we needed to do a dilation, half. Negative 1, and negative 1, 1. How'd you do? How'd you do? Is this hard to see? Kind of, maybe. A little bit. I can use a different color. I think this guy's garbage now. How'd you do? The quiz that I handed back, a lot of you just, I don't know why, maybe it was like, well, it was the first quiz that we took so far in this chapter, but a lot of you aren't labeling these points, and you see me do it every single time. So that's something that I expect that you do. So when you look through, if I wrote label, it's because you didn't label. Another thing on that quiz that happened was I gave you guys the rules for reflecting and the y equals x and the y equals negative x, and some of you just like didn't even read to see that I gave you the rules, or you saw them but you didn't use them, one or the other. So I know. All right, we're good. We don't need to do another one. Do we need to do another one? Do we need to do another one? No, let's do one more because this one has a reflection. The other two didn't have a reflection. Let's just do this last one. All right. So we have triangle FGH. So we've got 1, 2, 4, 4, 2, 0. A reflection in the x-axis is saying that we go from A, B, and since we're reflecting in the x-axis, the y values change. Left in the x values change, so I'm going to have A, negative B. Or maybe you don't need that rule and you could just look at the graph and figure it out. That one's one that I can easily just look at the graph. But if you want to use the rule, that's also helpful. I'll do both. So my F prime would be 1, negative 2. My G prime would be 4, negative 4. And my H prime would be 2, 0. So reflection in the x-axis, and then after that we're going to do a scale factor of 1.5x and 1.5y. So I'm multiplying each number by 1.5. Is this an enlargement or a reduction? Why is it going to be enlargement? Don't say because it gets bigger. Why is it going to be an enlargement? Yes, John?
Because the scale factor is above 1.
Because the scale factor is greater than 1. Exactly, yeah. Good job, John. For real, though. Oops, it's H. Here we go. Last two examples are, let's actually find the similarity transformation that trapezoid PQRS to trapezoid WXYZ. How do I know which one is the pre-image? Because they're not using. Which one is the pre-image? I see you. Okay, you just want to keep your hand up? Okay. I want everybody to think for themselves. How do we know which one is the pre-image? You do not, because you tell me that you know the answer does not mean I will call on you. That didn't make sense. Please let me know by show of hands who thinks they know the answer. That does not mean I'm going to call on you, okay? Somebody already really wants to say. How many people think they know the answer? Maybe, maybe, maybe. How many people don't know the answer? Interesting. Can I give you a hint of reading the directions? How many people think they know now? How many people don't know? A few of you still don't know. Okay, Alex, what do you think?
In the directions it says from PQRS to trapezoid WXY.
So which one's the pre-image?
PQRS.
Yeah. PQRS and turn it into WXYZ, then PQRS has to be the pre-image. And then the WXYZ would be the image. So are we doing an enlargement or a reduction? A reduction, it's getting smaller. I'm going to list the ordered pairs. I feel like that might be helpful for me. P is, oh no, you guys have to make sure I don't make any mistakes. -6, 3. Q, negative 330. R, it's negative 6, negative 3. Oops, that's not R, that's S. Eh. R is 0. Okay, so who has an idea? How could I get this one to turn into that one? Aaron, do you have an idea? He says scale factor 1/3. He wants to do dilation, scale factor 1/3. Let's see what happens to the ordered pairs when we do that. Notice I pulled out my pencil just in case this doesn't work. So I pulled out my pencil just in case. I like doing the color thing, but I'm a realist. I make mistakes. All right, so P prime. If we do, if we're doing 1/3 X, 1/3 Y, then P prime will be negative 2, 1. Q prime will be negative 1, 1. R prime is 0, negative 1. And S prime would be negative 2, negative 1. Let's see where that puts us. Negative 1, 1. 0, negative 1, negative 2, negative 1. You guys think Aaron picked a good first step? You think he picked a good first step? I think he picked a good first step. I think I get. Let's see if Emily can get the next step. Or I should say the last step. Anything's happening from this one to this one. Where's it reflecting in? Reflect in the y-axis. Okay. So if we reflect in the y-axis, that would be a translation where we do negative A, B. So we change the x values if we're reflecting in the y-axis. So I would have 2, 1, 1, 1. Did you notice I used the pen this time? What do you think that tells Emily? She's right. 0, negative 1, and 2, negative 1. So we've got 2, 1, 1, 1, 0, negative 1, and 2, negative 1. Looks good. All right, now you guys have one to try on your own. And then when we're done with this one, the assignment will be a big ideas assignment. Should be kind of an easy one, huh? All right, how many people in here found a dilation? People just show me hands. Who in here has found a scale factor? Okay, Stephen has not, so I'm going to help you get it, bud. Ready? If you look at, well, this one is a little bit more challenging. If you look at D to E, I'm just going to kind of use slope. It's like up 1 over 3. If I use slope, it's up 1 over 3. Stephen, down here, what would kind of correspond to the D to E? What corresponds to D to E? You can even look over here. What corresponds to D to E? ST. So if I go from S to T, I'm going to go 1 over 1.5. So how can I go from 3 to 1.5? So let's see if that works, okay? So if I reduce it by half, then I'm going to be going like x to x, or xy to 1/2 x, 1/2 y. I didn't write my ordered pairs yet. Okay, so if I do half, then I'm going to have -1, 1.5, and then I'll have 0, 2, 2, 0, and 0.5. And you notice I'm using the pencil right now because I'm not sure if I'm right. Why do I think I didn't graph that right? Does that look right? Does that look right? Does this look right to you guys? It doesn't look right to me. I mean, it looks like this is a dilation with that, but it doesn't look like that matches. Did I do something wrong, or what's what? Which number are you looking at? Oh, yeah, I don't know why I put 0 there. That would be why it didn't look right. See, I just need to always do my homework with you guys to help me out. Okay? So 0.5, 2 should be, that should make. Now does it look better? Yeah, it looks better now. Yeah. You want to say the next thing?
Yeah.
Oh, okay. So now I think there's multiple ways of doing the next thing. I am somebody who wants it done the shortest way possible because that's the way I live my life. So you guys might have answers that work, but I'm going to try to go for the shortest amount of steps. What were you thinking, Alex? Rotation 180. Let's try rotation 180 degrees. What is that rule?
It's
Or negative a, negative b. Okay, so now I'm going to take these points and I'm just going to change their signs. So we'll have 1, 1.5. Nope, negative 1.5. Sorry, this is d double prime. I didn't write my d prime in there either. Negative 0.5, negative 2. E double prime. Negative 2, 0. And 5. Bless you. Let's 1, negative 1.5. Negative 0.5, negative 2. Negative 2, 0. 0, negative 0.5. Boom, got it. Good job, guys. So we had a dilation, scale factor half, and then we did rotation 180. Did anybody try it a different way and still get the same answer? What'd you do, Maggie? Oh, you just did it do in one step? Yeah. Awesome. So you used a scale factor negative 0.5. and then that did it in one step. So, you know, I'm all about doing it the shortest way possible. That'd probably be the shortest way possible. But having 2 steps is also okay. So you guys have Big Ideas Online. You have 10 minutes to get a good chunk of that done. All right? Good job today.